guys so you can see what I'm doing. All right, go ahead and share Paint. And we're off. Okay, so I'm gonna make sure the chat's open. So if anybody has a question at some point, you can either raise your hand as like a participant, or you should be able to just like type something in the chat and I'll see it. Okay, the first question, I'm gonna write the question and then we're gonna do the question. This comes from the web assignment, but it's actually similar to something that's also on our written assignment. So the problem states you're given 2 points. You're given, I should actually be able to write, there we go. We're given the points -3, -4, and we're given the other point, which is -1, 10. And the question asks us, turn that down. The question asks us to plot the 2 points, find the distance between the 2 points, and find the midpoint between them. Okay, and I'll find a couple other things along the way. But first we need a couple things. First thing we need axes. That's what we really need. So I'm gonna make a line. I'm just gonna basically stick the x-axis down here. Why not? Give us plenty of height. And then I'm also going to give us a y-axis. And I should actually be able to do that. Here we go. Perfect. Actually, I'm going to move it over. There we go. That looks to be about in the middle. Okay. So we got all this going for us. So now what we need to do is we have our axes, and it is important to remember that this point here, this is your origin. And when I say origin, that means that is 0, 0. So the point where the y-axis and the x-axis meets, that's your origin, that's your 0, 0, everything goes off of that. Okay, so if we want to plot the point -3, -4, we're gonna go back 1, 2, 3. We're gonna go down 4. So 1, actually no, that's a +4. That is a +4. That's what the question asks. So -3/4 are going to go back 1, 2, 3. We're going to go up 1, 2, 3, 4. Okay, we got our point. Let's call it A, just so we can tell them apart. Now for the next point, -110. Again, we're going to go back, but we're only going to go back 1. Then we're going to go up. So 4, 5, 6, 7, 8, 9, 10. All right, and we're gonna make sure we label it so we can tell the 2 points apart. We're gonna call that thing B. So this is our A, this is our B. Okay, so we have the points plotted. Now, 2 things that they ask us to find the distance between them. The way you wanna do this, make a triangle. I see a lot of people, they either just look up the distance formula and they don't understand it, or they're just lost to begin with, which makes sense, right? Because it's a diagonal distance. I can't just count squares, skip from one to the other. But what you can do is you can actually go ahead, you can make a triangle here. You can make a right triangle, and you can find this hypotenuse here. That's actually how the distance formula works, is it finds that diagonal distance by making a triangle. Okay, so what's going to be the lengths on those? Well, this length here, the way the distance formula is set up, you basically want to take some point and subtract the other one's points. So let's do -3 minus -1. Well, that's going to be -3 plus 1, which is -2. Now, here's the thing, though. It's a distance. All distances are positive, so that's basically just 2. And when I ask you guys on the written assignment, find the distance between, find the vertical difference and the horizontal difference between the 2 points, make it positive. I really meant distance when I said that, because basically I just wanted you to find the different components you need for the distance formula and for finding the midpoint. But anywho, so this distance here is 2. And what we're going to want to do is we're going to want that thing. We're going to want it squared, but also we need this component. So here I would take, let's actually do it. If you do it the other way around, it just comes out positive. So let's do that for both of them. Because you can actually go ahead, you can take -1 minus -3, and that just gives you 2. So notice I took this thing's x minus, so I took xb minus the x coordinate from A, and that's how we got 2. So now do the other. So take the y coordinate from B and subtract the y coordinate from A. So this thing is a 10. This thing's up 4, and that's going to give us 6. So this is 6. So now, in order to find that diagonal, we're going to use Pythagorean theorem. That formula you know and love. So we've got 2 squared plus 6 squared equals something squared. So this is 4 plus 36 equals x squared. And we're calling this distance, we're calling that x. All right, but we don't want x squared, we want x. So this is also 40. Now, I could say x is just the square root of 40. However, yesterday you learned some techniques for actually breaking this down even more. Off the top of my head, I'm spotting that this is the same thing as square root of 4 times square root of 10. I can do that because they're like roots. So then the square root of 4 I know is 2, and we just have square root 10. There's nothing else you can break out of prison there. The other way you think about it is if you break apart 40, you basically just get 2 times 2 times 2 times 5. Well, it's a square root. There's nothing written here, so I know it's actually a second root. These two can help each other out. You're going to perish, so the 2 comes out. These guys didn't make enough friends, and I'm just going to leave it as 2 times 5. Hence, it's 2 square roots of 10. So that is going to be your distance between point A and point B. This is actually your distance right here, 2 square roots of 10. Any questions about that before I continue? Okay. The other question we were asked to get is the midpoint. Now, the midpoint has a fancy formula, and it's not that complicated, really. But at the same time, just look at it this way. The gap between these two, you basically just want average their x's, you want average their y's. There's 2 ways to go about it. So go ahead, and the x coordinate of your midpoint is the average of your 2 x coordinates. So xa, so the x coordinate of point A, plus xb, the x coordinate of point B, and you're going to average them, so divide by 2. Okay, so when we do that, we're going to get -3 plus -1 divided by 2. So that's going to be a -4 divided by 2, which is going to be -2. Okay, so that's the x coordinate of the midpoint. The y coordinate of the midpoint, same process. So you have the y coordinate of point A, you have the y coordinate of point B, you're going to average them. And when we do that, we're going to get 10 plus 4 divided by 2. So 14 divided by 2, and that's going to be 7. So your overall midpoint is just going to be -2, 7. That's one way to do it. The other way to do it is take like point A and give it half of this horizontal difference and give it half of this vertical difference. So if you took point A plus half that x difference and plus half of the y difference. And the way that looks is you basically just do -3 plus half of that x distance, so plus 1. And then you get 4 plus, instead of 6, you would give it 3. And that will also give you -2, 7. So there are two different ways. Quite honestly, this method right here, this confuses a lot of people. So you might not want to use. Okay, any questions about how we found the distance between 2 points and the midpoint? I think with that wrapped up, you should be good to go with regards to the written assignment. Again, print it off, write out everything on it, scan it, put that PDF in EduCat. It will only take PDFs. It will growl at both of us if we try putting something else in. But any questions? Okay. So let's keep moving along. And we got some simplification problems I want to talk about. So very dangerously, we have the very simple instructions of simplify. And that's all we're told to do. And we are given the problem. And the way it's written is we're given 4 times 3 to the negative 2 all over. And we get 2 to the negative 2 times 3 to the negative 1. Okay, so right off the bat, I'm looking at that 4. I'm saying, wait, there's another way to rewrite it. And that other way to rewrite it is, for me personally, I would rather write that as 2 squared. And then everything else so far can stay the same. Now, I said you can only play with the exponents when you have like bases, right? So I can't do anything like this 2 squared can't interact with this 3 to the negative 1. There's no play between those two. The good news is I've got 2 different sets of like bases. So basically what this turns out to be is, if you remember the subtraction rule from yesterday, we're going to end up with 2 squared, but it's not 2 squared. It's going to be 2 to the 2 minus the negative 2 from the bottom. So it's going to be the top exponent minus the bottom exponent, and then do it again. So times 3, top exponent, negative 3, minus the bottom exponent, negative 1. All right, and when we do that, 2 minus the negative 2, the negatives cancel each other out to make a plus. So I get 2 to the 4th times, okay, so we have 3 to the negative 3 minus negative 1. Those cancel out to make a plus. So we're going to get 3 to the negative 2. In terms of actually calculating this, 2 to the 4th is going to be 16. I told you when you have a negative exponent, it goes in the bottom of the fraction. So it's going to be 3 squared in the bottom here. And that's going to be 16 over 9. Now, as I was telling somebody yesterday, when you're typing things into WebAssign, you do not want to give it a decimal. So do not see 16 over 9 and go grab your calculator to crunch that and type the decimal into WebAssign. No, give it the exact answer. That goes for square roots too. If you have 2 square roots of 10 and you go bust open your calculator and say 2 times square root 10 and you get, I don't know, 6 point something, WebAssign will not take that. It wants you to do the algebra and it wants you to have the nice simplified form. I actually got a message from somebody. I didn't realize it was this picky, but somebody messaged me and said it would not take square root 40 as an answer to something. It wanted the 2 square roots of 10. So I assume that applies here too. 16 over 9. You can't do anything with that, but give it 16 over 9. Don't give it 16 over 3 squared. Don't give it 2 to the 4th times 3 to the negative 2. Do the work, give it 16 over 9, but don't crunch it as a decimal. It won't like the decimal. Questions about this process?
I actually think I did put square root of 40 and I think it worked. I can check later.
Yeah? Okay. Hey, no, I'm fine with that. Because again, if I'm grading it, if you got square root 40, as far as I'm concerned, you did the work. You got the 2 squared plus 6 squared. Okay, good to know. I thought I had somebody message me and they said it wasn't taking square root 40 and they're like, what do I do? What do I do? So, okay, good to know. We can look into that later. Awesome. Anything else? I got another simplification problem for us then. So again, more just simplification. I say that so lightheartedly, but this one's a bit tricky. So we get 24 times, and this is also similar to the written assignment. But we get x plus y to the 4th all over 15 x plus y. Okay, so 24 divided by 15. First thing I'm spotting, they both have a 3 in common. So this is actually going to be 8 over, for numbers at least, it's going to be 8 over 5. They both had a 3 in common, and we took those out. Now, as far as the other term here, so this x plus y term, so think of it again as one solid thing. I'm actually going to erase some of this and give us more real estate. But basically, it's going to end up as, if I can actually get the marker, x plus y to the 4 minus 1. If the exponent isn't written, it's a 1. So top exponent minus the bottom exponent. And basically what we're going to end up with is 8/5 x plus y to the 3rd. Now, we can be done here. Actually, I believe this is basically your full, complete, done answer. But hypothetically, you will be asked to FOIL this out. I'm going to actually explain that process here, but if you're just curious what the answer is, this will end up being x cubed plus 3x squared y plus 3xy squared plus y cubed. So if you need to simplify, I know that's what the answer is going to be. I don't think so. I think it was actually taking x plus y quantity cubed, but we'll check in on that. Like I said, I'm going to explain that 3-part FOIL later, but for right now, does anybody have any questions? Okay, then we're going to do a little bit of vocab, and then we're going to go straight into the math then. So you have 5 assignments that are due this week. 2 of them were more or less review. I didn't talk too much about them because I thought they would be review for you guys. Of course, I take questions. And if you guys have questions, you should always feel free to fire those off. But some of the questions at the beginning of one of those were more along the lines of vocab. And I do want to discuss that a little bit. I talk about terms, and I've talked about terms. Some of them have variables in them, which we generally use letters for. And then, just regular things with numbers. But when you are talking about having variables and different exponents of variables, then at that point, we don't just have terms, we have polynomials. So today's discussion is more or less just going to be on polynomials. And polynomial is really just a fancy math word for saying you have some kind of an expression, you have some kind of a term with multiple powers of x. Or multiple powers of some variable. That's it. You just have variables in there, and they may or may not have different exponents in there. And the best thing I can tell you is if you have just one term all by itself, let's call it x squared. Okay. If you only have one thing, this is a monomial. And you're going to get the pattern here real quick. Okay, now what if it was x squared plus x cubed? Or actually, let's make it something even wackier. Let's make it like x to the 7th. Okay, now this whole complete thing is going to be called a binomial. And like I said, real easy pattern spot here. Because I'm sure at this point you can guess the answer to, if I ask you, if we had a third term here, what this is going to be, I bet a whole bunch of you are saying right now to your screens, that's a trinomial. And that's the idea, is when you have yay many terms of different exponents, it is some kind of a polynomial. That's a general phrase. Now, the way we work with polynomials, We can do addition, subtraction, multiplication, division. We can do the whole 9 yards. Now, those last two are a bit more complicated, but the addition, subtraction, I know you guys can do. So if we have, let's say we have two polynomials. Let's say we have x squared plus x to the fourth. Let's actually write this the way we should. If I have x to the fourth plus x cubed. Actually, no, I'm going to show it wrong first. X squared plus x cubed plus x to the fourth. The math's going to be right. The form's going to be wrong. And it's an easy fix. 2x squared plus 3x cubed plus 4x to the fourth. Okay, how do we add this? Now, the way you actually go about adding this, it's actually really simple. You can basically just stack them because the way you're going to do it is you're going to add like terms. So cubes go with cubes, squares go with squares. So 2x squared plus 3x to the third plus 4x to the fourth. So when we add these, I notice that these two, we call these like terms because they have the same variables and they have the same exponent for every single one of them. So we can add like terms. We can subtract like terms as well if we add negatives in here. But the way this is going to work out, I have 1x squared plus 2x squareds, that's 3x squareds. 1x cubed plus 3x cubes, I have 4x cubes. And at this point, you guys probably getting the pattern here, and we're going to have 5x to the fourth. Now, one thing to consider here is that we actually don't usually write it this way with the exponents getting larger as you read from left to right. We actually write it a different way, and we usually do it with the largest exponent coming up front. So 5x to the fourth plus 4x to the third plus 3x squared. This notation where I write it in this way with the largest exponent up front and the smallest one in the back, this is called standard form. And standard form is nice for a whole lot of reasons. But the main one is it makes it easier to, if you write everything that way, it makes addition, subtraction, multiplication much, much easier. A couple other things to consider when we're looking at this. The degree of this polynomial. So we have three different terms here, right? We have a 5x to the fourth. We've got a 4x cubed. We have a 3x squared. The degree of a polynomial is the highest exponent you have. So the highest exponent we have is a 4. So we're going to have a degree of 4 on this polynomial. Another thing to consider is the leading coefficient. So these numbers that are attached to these different x terms, so we have a 3x squared, we have a 4x cubed, we have a 5x to the fourth. These are all coefficients. Now, this one over here, the 5, is special because that's the one that's way out in front. It's in front of everything. So we call this the leading coefficient. All right. So now we've got that out of the way. Now I want to talk about, so addition, subtraction, really straightforward. You can already do all of that with just what I've shown you. But now let's talk about how multiplication works. Now, I've already shown you a little bit of how it works, right? So if we have an ax plus b, cx plus d, and let's say those letters, those are just numbers, right? I just don't feel like making them up. The way you multiply this out, you FOIL it. And we've already had some practice with that. First, outer, inner, last. You've already got some practice with that process. You might have actually been exposed to that before you got into my class. That's fantastic. But that's not the only way that we multiply polynomials. So if you have two binomials here, which is exactly what we have two terms on the left, we have two terms on the right. When you multiply that all out, you get 4 different things and you add them all together. That's foiling. However, not everything looks like that. You're not always going to have just 2 binomials. So you have to have other tricks in your bag. Some of them are easier than others, but some of them we need to talk a bit more about. So for example, one thing, so these are all just homework problems that I actually ripped out of your web assignment. So you might be a bit more interested in these, but let's go ahead and take, so just for some examples, let's do 3x times the quantity of x squared. And when I say the quantity of, I mean the chunk. So that's why I'm always, whenever I say the quantity of, I'm referring to the chunk inside parentheses sign that you should treat as one giant term. But anyways, 3x times the quantity of x squared minus 4x plus 1. Okay, the way we do it, we want to go ahead and we want to multiply this 3x on each one of these terms separately. So I'm going to take 3x times x squared times negative 4x and times 1. And when we go ahead and we do that, 3x times x squared, that's going to be 3. The x has an exponent of 1. So 1 plus 2, we're going to get 3x cubed. Plus, so now 3 times negative 3x times negative 4x. Actually, we don't need the plus because what we're going to write is a minus. So we get minus 12x squared. You add the exponents. And then finally, plus 3x times 1 is just going to be 3x. Anything times 1 is always itself. Nice. Any questions about this process? If we were being really pedantic and really want to over-describe this, this is a monomial times a trinomial. I would not expect you to think about it in that way. I would expect you to see, oh, I multiplied the 3x on each part of that. That's more useful. All right, so another problem from your homework is y squared times the quantity of 4y squared plus 2y minus 2. And when we go ahead and look at this, again, always remember to add the exponents if you have like variables or like bases, just in general. So 1 times 4 is 4 for our coefficient. And then y squared times y squared, we add the exponents, we're going to get y to the 4th. Plus 1 times 2, so 2 for our coefficient. And then y squared times y to the 1st, y cubed minus 2y squared. All right, so those are relatively straightforward, but just in case you hadn't seen it without the foiling, here's how you take just a single term times a polynomial. You just basically spread it out, you distribute it across the other quantity. So let's level up a little bit and let's try some foiling. So 2x minus 3, 6x plus 1. Okay, who wants to unmute themselves and give this a shot? What should I do?
You're going to do 2x times 6x.
Perfect. And what's that going to be?
12x squared.
Perfect. Keep going.
Plus 2x.
That comes from that. Perfect.
Minus 18x. And minus 3.
Perfect. Okay, and when we go ahead and we add like terms, the only things I can really combine are going to be this plus 2x and this minus 18x. So we're going to get 12x squared minus 16x minus 3. Perfect. Okay. Sounds fantastic. That's, again, a nice little demonstration of foiling. Next one is going to be a bit more complicated. I'm definitely going to take control of this one. There's 2 different ways we can do it. One is basically just a big foil. The other one you're actually probably going to like better and you might end up doing as just like a main strategy. But let's go ahead. Let's take a look at the problem. X squared minus x plus 6. X squared plus x plus 4. Again, ripped straight from your homework. This is exactly the kind of stuff you're going to be doing not only on the homework, but also probably on the exam. So if I were to look at this, the first thing you could think of is basically just do a giant FOIL, right? Do x squared plus x plus 4, write out those 3 terms. Then do minus x times x squared, minus x times x, minus x times plus 4. Great. And then you just keep going. And you do the same thing with the x, or with the 6. 6 times x squared, 6 times x, 6 times 4. You can do all that. You can get all your 9 terms. That's all nice and wonderful. The only problem is when you do that, you end up with a list that looks like this, where you have x squared, x number, you get x number, number, and then it just keeps going. So, and then you have to search, you have to say, oh, this x and this x go together, these numbers all go together. It's a lot of bookkeeping. It's a lot of keeping track of things. And that's all well and good if you like that and that works. One other thing I want to show you though is another way that this works. So let's write out the terms. So x squared minus x, 6. And then let's go ahead and write out x squared, x, and 4 over here. So what I've made is I've basically made a little table here. And what we're going to do is we're going to basically just multiply it the same way. But I'm going to show you a neat thing that comes out of it when you use a table to do it. Okay, so x squared times x squared. I don't want the eraser. I want the marker. There we go. So we're going to get x to the 4th. X squared times negative x. We're going to get negative x cubed. X squared times 6. 6x squared. So at first glance, you might say, you know, Andrew, you're just doing the same thing you were talking about earlier. What is so nice about this method? This is basically just what we've been doing. There's no real difference here. And you're right so far. But here's the neat little thing. If you go along the diagonals, okay, so x to the 4th is the only x to the 4th that we have. Then if you go along this diagonal, boom, there's your x cubes. Then if you go along this diagonal, here's all of your x squareds. So you just add them up. Here's all of your x's, and then here's your number. This is the other reason it's really nice to write everything in standard form, is when you do so and you slot everything into this table, you get these nice diagonals that come, so you just add everything up. So the end product of this multiplication, you're going to get x to the 4th. Your x cubes, you have 1x cubed minus 1x cubed, so those actually both cancel. All right, and then we get 4x squared minus x squared, so we have 3, and then 3x squared plus 6x squared, so we get plus 9x squared. Then for the x's, we get 6x minus 4x, so we get plus 2x. And then for a number, we get plus 24. Now, I usually, just for your guys' benefit, I usually just say a number. A lot of times in your text or in a problem, they will call this just a constant. So if it does not have any kind of a variable attached to it, generally in mathematics, it's referred to as a constant. So we have our constant term, we have our 2x, we have our 9x squared, we have our x to the 4th. Any questions about how I did this trinomial multiplication? If you do, that's fine, because I'd rather you guys ask questions now, get it all sorted out now, rather than, you know, try going at the homework and say, oh, shoot, I'm not sure I know how to do this. Okay. So let's do another one. And by another one, I mean, let's do a 3-parter. And I'm actually going to do it with the table. You can do it with the table. You can do it without. I'll show both, actually. So one example problem is, let's say you have 5x plus 2y quantity cubed. Okay, that's a problem because we haven't done one of those before. Good news is it's not too hard. So if we were to, what you can do is you want to break this apart, and you want to go after the squared and then do one more, right? You've done foiling. You can use this table now. You know how to take on, you know, multiplying 2 terms. So then what you do is you get that answer and you multiply it by another 5x plus 2y. So let's go ahead and do that. So if you're foiling 5x plus 2y, you would go ahead and you'd write it out like this. And then for first, you would get 25x squared. For outer, you would get plus 10xy. when you have two variables, they're different variables. You just put them next to each other. A lot of people prefer to write them in alphabetical order, but they might not always do that. So it's something to keep in mind. Plus 10xy again when we do inner, and plus last 4y squared. You end up getting the same thing if you did this with the table, 5x, 2y, 5x, 2y, 10x squared, or no, 25x squared. Ten xy, 10xy, 4y squared. You don't really need it so much because you can already pretty easily see that those are like terms and you can add them, but it is a different way to go about it. So either way, this is going to be our answer. All of this is equal to this. So now we just need to multiply this by another 5x plus 2y quantity. Okay, this is where you may want the table. I'm going to show it again both ways, doing it with the FOIL, doing it with the table. So let's give a 5x to each one of these four terms, and now I'm going to multiply a 2y times each of these four terms. Okay, and when I do that, so I'm going to do the 5x is going to be green, multiplying by 5x is green, and I'm going to do purple is multiplying by 2y. Okay, so 5x times 25x squared, we're going to get 125x cubed. You don't have to know that off the top of your head. I just do. You can use a calculator for that. But going on, so then 5 times 10, we're going to get 50. Now, the x exponents are going to add. We're going to get x squared. I'm going to leave the y alone because I did not multiply it by another y. Do it again. So we get another 50 x squared y plus, and now that's going to be 20 xy squared. So now multiplying all four of these terms by 2y, we're going to get 50 x squared y plus 20 xy squared plus another 20 xy squared plus 8y cubed. Okay, so now we just need to go through, we need to find the like terms and slot those together. There's only one x cubed, so that's all by itself. X squared y, I'm noticing we basically get these three terms are all going to be that. So we're going to get 125x cubed plus 150 x squared y. This is an xy squared. This is an xy squared. This is an xy squared. So we're going to end up with plus 60 xy squared and then plus 8y cubed. Okay, any questions about this three-part FOIL before I do anything else? Okay. If you were to do this with the table, first of all, I would say you should probably combine these. And I could have done that for this as well, but I kind of like seeing the threeness that comes from all of these. But anywho, we get 25x squared, 20xy. I'm going to combine these two to make my table. 4y squared. And then on the other side, so this is all from FOIL. Okay, and then we're going to multiply this all times 5x and 2y. So again, same thing we were doing earlier. Go ahead, multiply everything out, and you want to look at the diagonals to see what jumps out. And it's not a bad process. Like I said, you may prefer this, you may not. There's no there's no right way to do these kinds of problems. It's more just personal preference. Okay, and again, we get the when you write everything in standard form, you get the like terms on the diagonals. And I can already see 50x squared y, 100x squared y, that's your 150. The 20 and 40, that gives you 60. The 8y cubed and the 125x cubed, those are both nice, neat, nothing to worry about there. Questions about the table method? Okay, now I am going to show you a shortcut here. Two shortcuts, actually. You might already consider the table a shortcut. It's not really a shortcut. You're doing the same amount of work. It's just laid out nicer. Some people do it, some people don't. Me, it depends on my mood, more or less. But here are basically two multiplication shortcuts. And this only works when you have the same term cubed. So if you have ax plus b quantity squared, you will always and forever, no matter what you plug in for a, no matter what you plug in for b, those are stand-ins for numbers. Those are stand-ins for numbers. You will always get a squared x squared plus 2 abx plus b squared. You will always get that. If I go ahead and I demonstrate that with 2x plus 5 squared, I get 4x squared. Square the 2, square the x squared, plus 2 times 5, you end up with 20x plus square the 5, 25. You can go ahead and you can double check me by doing this with foil. Let's use a different color. Two x plus 5, 2x plus 5. Go ahead, foil that out. What do you get? You get 4x squared right off the bat with first. When you do outer, you get plus 10x. When you do inner, you get another plus 10x. Plus last, you get 25. Same thing, same thing. Go ahead, put the like terms together, 10x and 10x. They go ahead and make 20x. So this shortcut here, ax plus b quantity squared, you will always end up with that product. The other shortcut, this is a bit of a longer one. I will never make you write out, hey, what is this thing right off the top of your head? 3 seconds, go. I'll never make you use these shortcuts. I'm more just pointing them out because they're patterns you're going to see anyway. I'd rather you see them from me. So when you FOIL this thing out, you're going to get a cubed x cubed plus 3 a squared x squared b plus 3 ax b squared plus b cubed. Always and forever, I'm going to get that. Always and forever. If you had another variable here, like if you had a y attached to the b, wherever the b shows up and whatever exponent the b gets, that would be the variable attached to b gets. Like I said, those are just shortcuts. You don't have to use them. I actually prefer you don't use them. I'm just showing them to you because if you see them somewhere else and you're like, hey, what the heck is this? I'd rather you see it first from me than try to figure it out off like some YouTube video. Okay, so we've got about 6 minutes here. Let's go ahead. Let's just literally pull up some homework problems. Polynomials and special products. Okay, so vocab. Let's see. Give me a fun one. We need a fun one. That's a fun one. Okay. I think I'm going to do one more problem here just because it does look a bit more on the fun side. And when I say fun side, I mean it looks fun for me. I'm not sure how fun you'll think it is. Maybe by the end of the semester you'll think it's fun. But you need to tell me what your relationship with this in math for that extra question on the written assignment anyway. So the problem is 4x squared minus x plus 16 times, I'm already just going to put this in the table, x squared plus 3x plus 4. Okay, does somebody want to unmute themselves and tell me what I should do here?
All right, it's going to be 4x to the fourth.
You answered the last one, didn't you?
Yeah.
You know what? Good for you. Let's go. All right, let's do this top row. What do you got?
Negative x to the third and 16x squared.
Perfect. Next row.
12x to the third, negative 3x squared.
Perfect. 48.
48x.
Yeah.
And then 16x squared minus 4x and 48. Or no.
No, that's going to go a bit higher. That's actually going to go all the way to 64.
Yeah.
Okay, perfect. Nice job. So we've got that covered. So we've got our table all made for us. So now what you can go ahead and you can do is you can draw diagonals to see the like terms, and then you can go ahead and add those like terms. So we already know that this product is going to end up with a 4x to the fourth. We don't need to do any addition for that. But then what you can go ahead and do is you can just go along diagonals. So for our x cubed term, we're going to get plus 11x cubed, 12 minus 1. Then we get 16 plus 16 minus 3. So it's 32 minus 3. So we're going to get plus 29x squared. We get plus 44x plus 64. Okay, and that's how I would do that problem. Real simple, real straightforward when you have the tools. When you don't have the tools, you end up staring at it and you're like, oh, shoot, not sure what to do here. And I'm staring at the answer here. Looks like we got it. Awesome. Okay. So then just a couple quick programming notes. I see 30 out of 35 of you guys have gotten onto the website and started doing the homework. I'd like that to be 35 out of 35. Again, your homework's due Saturday. I don't know if that's like 12:01 a.m. it's on Saturday or if it's midnight on Saturday. Not sure. I have to check that. So might want to get going on that, especially since Math Lab's not open this week. Written assignment, that's due noon tomorrow. So get that done, ASAP. Print that out, write out your work on it, scan it as a PDF, submit that PDF file on EduCat. I really would appreciate if you did the extra question on the back. It's 3 points for you, and it tells me, what you're coming into this class with as far as math goes. You'll see when you look at it if you haven't already. And then, so next week, we're going to keep trucking with this. As far as I've heard, we are a go for in-person attendance starting next Monday. So as long as that's the case, green team, you're showing up, you're allowed to show up in person on Monday. Gold team, you are zooming in for Monday at 8 a.m. So it'll be mixed attendance. Don't worry, I'm going to be wearing a mic. So gold team, you're going to be able to hear me just as well as green team. And I'm going to be projecting just like this so that everybody can see my work. So shouldn't be too much of a departure from the setup I've had going the last few days here. Does anybody have any question about how attendance is going to work? Okay. Then I think that's about it. It's 49. I'm going to let you guys go. I'll stick around for like a couple minutes if anybody has questions. And then I've got my own class at 9. So, all right. Thank you guys.
I have a question.
Hopefully I have an answer. What's up?
I'm pressing submit on the web but nothing's happening.
Ooh, that's wonderful.
Like, is something supposed to happen? Is it, or do I just like, does it just submit on its own?
It should submit. Okay, do you have like green check marks by all your answers?
No.
Ooh, okay.
Oh yeah, I do. Yeah, I do. But not some of the answers are off and wrong.
Okay, so as long as you have a green check mark or a red X by every answer, that means you have submitted every answer and there's
Oh,
nothing
okay.
else to do. So
Okay. But it says submit at the bottom though.
yeah. And that's just there's just another submit button down there. Yeah.
Okay.
Yep. But
Okay,
as
thank
long as every answer has something by it, then you
Okay.
have submitted every answer.
Okay, thank you.
Yeah.
So the second example you did when we were foiling, I think
Which one's that?
the y squared multiplied by 4y squared plus 2y minus 2. I think it was the second example, maybe. There, right there. No, down a little bit.
Oh, okay. Yeah. Okay.
So could we simplify the final answer because all of the coefficients are divisible by 2?
No. That is simplified. So just because you can take a 2 out of all of them does not mean that makes it simpler. So there's no like equal sign that's like imperiling us to divide by 2 or divide by 3 or anything like that. So no, just leave them.
Okay.
Good
I
question.
was curious
Good
about
question.
that.
You can take a 2 out of all of those for like this question right here.
Mhm.
And you can take a 3 out of all of these.
Right.
But the question actually told us, distribute these things. So that's what we did.
Okay.
You'll
All right.
actually end up taking the 2 out. You'd be able to take the y squared out when we do the opposite. When we do factoring and we're trying to do the opposite of distributing, when we're trying to rip as much out as possible, you're going to do exactly that. But for right now, no.
All right. Thanks.
Yeah.
Can you go over the second simplified problem, just up the page a little bit?
This one?
Yeah, I don't get it.
What don't we get?
I understand up until the 8/5 times xy cubed. I don't understand the last part.
Okay, this last part you don't need to understand because actually, this is where you can stop.
Okay.
I just foiled that in my head. That's why I did. So you don't even need it.
Okay.
Good question though.
Thank you.
Yeah.